The first concept I want to introduce you to is something called functions. And just as we perform many different functions, it could be mother, father, son, daughter, we can also get our code to perform different pieces of functionality. Now, if we think back, we've actually already come across functions, and I've been referring to them every time we've needed to use one. If you take a look at this link in the course resources, which takes you to the Python documentation, then you can see that Python has a whole bunch of built-in functions that we've been using. For example, the len function, which gives us the number of items in a collection, or the int function, which turns something into an integer, or the print function, the range function, and other ones that we haven't seen yet. If you head over to the day 6 starting replit and go ahead and fork a copy of it, then we can start typing one of the functions that we've been using a lot, which is the print function. And the reason why we know it's a function is because it's the name of a function followed by a set of parentheses. Now we know that if we put something inside these parentheses, say for example hello, then when I run the code, whatever is inside those parentheses will get outputted over here in the console. Now, all the functions work pretty much the same. So if I wanted to use the len function to see, well, how many characters are there in this word hello, I again put my hello inside the parentheses, and because of the parentheses, we know that this is a function, and then I can save the outcome of this length function to a variable. Say, let's call it number of characters, numchar, and then I can go ahead and print it in order to view it inside the console. So let's print the num underscore char, and now you can see that this len function gets to work, calculates the number of characters, it's 5, and then it gets printed. So all of this functionality has been achieved by these built-in functions from Python, like print and len. Now, what if we wanted to make our own functions? How would we do that? Well, if we want to make our own function, we first start out with a keyword, which is called def. And this is because we're creating or defining our function. Now, after the def keyword, we can give our function a name. And I'm just going to call it my function. Now, the thing that differentiates a function from a variable, however, is the parentheses. So after the name comes the parentheses, and now the final thing, the finishing touch to our function definition, is a colon, because that says everything that comes after that line and is indented belongs with the function. Let's make a really simple function that just has 2 lines of code. Maybe it prints hello, and then it prints bye. So now I've created my function. I've placed the lines of code that are associated with this function all indented after the definition. But notice how if I go ahead and run my code, actually nothing will happen. And the reason is because we haven't yet executed the function. Now we can define lots and lots of functions ahead of time, and it's only when we actually need it do we go ahead and trigger it. And to trigger it, or in programming lingo, we would say to call the function, all we have to do is type the name of the function, which is my function, and then to add the parentheses and any necessary inputs. In our case, our function doesn't require any inputs, so we can leave the parentheses blank again. And now, if I go ahead and run my code once more, then you'll see that by the time the computer reaches line 5, it's going to search for this thing called my function. It sees that it was defined right here on line 1, and it goes through all of the content and executes them in turn, line by line. And that's why we get hello and bye being printed here. So just to recap, this is how we create a function in Python. There's 2 steps to it. The first step is to actually define the function, to specify what it should do. And we do that by first using the def keyword, and then we give our function a name. So for example, in this case, I called it my function. And then comes a set of parentheses and a colon. And then after that, we get to put the lines of code which will be included in this function. And remember that these lines of code which goes into the function, which will be carried out when this function is triggered, must be indented like this. So once you've defined the function, you've created the recipe, the next step is to actually use it, which in programming lingo, we would say calling the function. And we call the function just by specifying the name and a set of parentheses. And once the computer sees this line of code, it'll know to go and carry out all the instructions inside where we defined our function. And to learn about functions, I'm going to introduce you to something that's very similar to Carol the robot. The robot is going to be something that is just going to perform the tasks that we want it to, and no more and no less. So, for example, if we wanted a robot to go to the store and pick up some milk for us, we can't simply just tell it, oh yeah, just go and buy some milk, because it won't know how to do that unless we give it specific instructions, such as leave the house, walk 2 blocks to the right, walk 4 blocks back, and then 2 blocks to the right. When you go to the store, give them some money, and then take the milk and come back. We have to program each and every step. But say if this functionality of getting the robot to go and pick up some milk for us is needed every single day, then we have to write out all of those instructions day after day, day after day. And at some point, our fingers are going to hurt, right? We're typing so much code that's repeated because we don't have a way of bundling all those instructions together. And that's where functions come in. Functions will give us a way of referring to all those instructions at the same time. That way, we can give our robot a single instruction and it will carry out all of those little steps for us and get us some milk. Now, to try this out yourself, I want you to head over to the course resources and click on the link that takes you to Reborg's World. Now, Reborg's World is very similar to Carol the robot that I showed you earlier on, but it allows us to write Python code. And it's very easy to get started. Now, we've got this area here, which we're going to use to write our Python code. And then once we're done, we can click on play to run the Python code and see the instructions carried out by our robot. If you click on Reborg's keyboard, you can see all of the functions that we can use to command our robot, like move or turn left or build a wall, etc. Let's see if we go ahead and run this line of code here, move, what happens. When I click play, you can see that our robot moves forward in the direction that it's facing by 1 step. So if we wanted it to move, say for example, 3 steps, all we have to do is to call the move function 3 times. Now let's reset by clicking the return button to return our robot back to the starting position. Now let's click play again in order for our robot to carry out the new instructions. Notice how all the instructions were carried out very quickly. To execute each instruction 1 step at a time, line by line, we can use this step through button. This button allows us to see how each instruction is executed. And after each instruction, it pauses and highlights the next instruction. This is very helpful for debugging. So notice how we're highlighting line 2. So if I click on step again, it's going to carry out that function, and then it's going to carry out line 3. And finally, it reaches the end, and that's the end of our code. Now, in addition, we can use some of the other commands in the keyboard. For example, turn left. If I decide to say move 3 times and then turn left, and then maybe move 3 times again, can you predict which square the robot is going to end up in? Are you ready? Let's go ahead and run the code. There we go. We end up on the square 4, 4. It moves 3 forwards, turns left, and then moves 3 steps again. because that's what we told it to do with our Python code. So now here's a question. If you take a look inside the set of commands, you'll notice that there is move and there is turn left, but there is no turn right and there is no turn around. So how could we use a function to create those commands? Because of course we could just simply write turn left and then turn left again. And this would effectively turn the robot around, right? But if we want to do that many times, say for example, if we wanted to go to 3, turn around, go back to 1, turn around, go back to 3, then we would have to write code that looks a bit like this. We would have to say move 2 times to get to square 3, turn left, and then move 2 times again to get to 1, and then turn left again in order to turn around. This is all the code we would have to write to achieve this kind of effect. But instead of all of this, we could just define a new function. So we use the def keyword to say that this code is defining a new function called turn around. And this function is simply going to be turn left twice. And remember, all the code that's going to go inside the function has to be indented. And now, instead of writing turn left, we can simplify our code by telling it to call the function turn around. And we can do that here, and we can do that here. So now, when we run the code, you'll see that it does exactly the same thing as before, but this time we've cut down 2 lines of code. So instead of 8 lines of code for our instructions, we only now need 6 lines. And you can see that the more that you need to use this function, the more typing it will save you. But more important than reducing the number of lines of code is that our code has also become a lot more readable. So the turnaround function is much more clear than having turn left twice. Now let's see what happens when we use the step through button. Look closely at how each line in our code is executed. So now we're going to carry out the move by 1, and now it's going to call turn around, that function. And it jumps over to find this function and carries out the code inside, in turn, from the top to the bottom. So turn left, and now once that function's done, it goes back to where it was before and continues running. Move, and then turn around again. So here's your challenge. Try and create a separate function that turns our robot to the right. Pause the video, head over to the course resources, and click on the link that takes you to Reborg's world, and then go ahead and create your own function called turn right. All right, so this should be pretty simple because all we have to do is to define a new function called turn right. And this function is going to simply be turn left 3 times. Because turning left 3 times is going to effectively turn our robot right. So even though we only have this one way of turning our robot, we can define our own functions to give it many other commands that it could use. So now, using this turn right function, see if you can write some code that makes our robot draw a little square going from here to here, then to here, and back to the beginning. Once you're done and you hit play, this is what should happen. So pause the video now and see if you can complete that challenge. All right, so let's go from the beginning. We start out facing right at the position 1, 1. In order to draw the square starting from this way, we have to first turn left. And then we have to move 1 step, and that should take us to here. And now we have to turn right, move 1 more step, turn right again, move 1 more step, and finally turn right for the last time and move 1 more step. So using our awesome function means that we don't have to write out turn left 3 times each time we need to turn right. So our code can just be 8 lines long instead of 14 lines long. And we're using our function to cut down on a lot of typing. But not only are there fewer lines of code, look at how much more readable our code has become thanks to our turn right function. It's now so much easier to read, turn right, and understand what it needs to do rather than seeing turn left 3 times in the code. So now it's easier to read and it's easier to follow the logic in our code. In the next lesson, I've got a challenge for you. Head over there and apply what you've learned about functions to try and solve it. I'll see you there.